Good wishes to all of you. Environment and Ecology, Part 1 Introduction, Chapter 1 The Global and National Environment, an Overview of the Crisis. Keep the fire going with this motivation and quiet. A journey of 1,000 miles must begin with a single step. Liu Chu, ancient Chinese philosopher. We are facing a devastating pandemic, new heights of global heating, new lows of ecological degradation, and new setbacks in our work towards global goals for more equitable, inclusive, and sustainable development. To put it simply, the state of the planet is broken. Antonio Guterres, UN Secretary General, December 2, 2020. About this chapter provides an overview of the current global and national environmental issues. While you may not get question in the UPSC examination directly based on this chapter, this overview is essential for acquiring an overall understanding of the environmental crisis that will help you answer questions in the mains exam and the interview. You may not understand all the new terms in this chapter. Be assured that many of them will be explained again in the subsequent chapters. Assess the glossary and the index if you are keen to understand them now. Lead story. The COVID 19 pandemic has had a devastating impact on our lives. This story explains how our actions caused the pandemic and how we can protect ourselves against future pandemics. What will you learn in this chapter? What do the global and national environmental indicators show? What are the causes of the environmental crisis? What are renewable and non renewable natural resources? What is our ecological footprint? Have we crossed any of the planetary boundaries? What has the world done about the crisis? What can and should be done now to save the planet and humanity? Keywords and phrases that you should remember: Anthropocene, biological capacity, carrying capacity, climate change, coronavirus, COVID 19, Earth overshooting, ecology, ecological footprint, environment, environmental performance index, exponential growth, global warming, non renewable natural resources, pandemic, planetary boundary, polluter pays principle, precautionary principle, renewable natural resource, sustainable development goals, zoonotic disease. Conference, conferences, organizations, reports, agreements, etc. Agenda 21, Earth Summit, Global Footprint Network, Global Forest Resources Assessment, Kyoto Protocol, Living Planet Report, Niti Aayog, Paris Agreement on Climate Change, State of the World's Forests Report, Stockholm Resilience Center, UN Convention on the Law of the Sea, UN Convention to Combat Desertification, UN Environment Program, UN Food and Agricultural Organizations, World Health Organization, World Meteorological Organization, WWF. Lead story: The environmental causes of the COVID 19 pandemic. A single species is responsible for the COVID 19 pandemic, and that is us. In May 2020, at the height of the first wave of the pandemic, the UN Environment Programme UNEP published a short report. Science points to causes of COVID 19. It includes the following points. What kind of disease is COVID 19? COVID 19 caused by the coronavirus is a zoonotic disease that jumps from animals to humans. Zoonotic diseases are a significant threat to human health. Our lack of prior exposure to such diseases means we have no existing antibodies against them. Recent zoonotic disease outbreaks includes SARS 2002, avian influenza or bird flu 2004, HINI or swine flu 2009, MERS 2012, Ebola 2014 to 15, Zika virus 2015 to 16, and the West Nile virus 2019. Almost a centuries worth of global trends confirms that zoonotic diseases outbreaks occur more frequently than ever. On average, three novel infectious diseases emerge in human every year, and 75% of all emerging infectious diseases are now zoonotic. What has been causing the recent spike in zoonotic diseases? Human actions facilitate coronaviruses. Coronaviruses are leaping to human more frequently because we provide them with more opportunities to do so. Over the last 50 years, the human pollution has doubled and the global economy has almost quadrupled. Rapid migration from rural to urban areas and the creation of new urban centers has affected demographics, lifestyles, and consumer behavior. Our evolving lifestyles have dramatically altered and land around us. We have cleared forests and other natural areas to create space for urban areas and settlements, agriculture, and industries. In doing so, we have reduced overall space for wildlife and degraded natural buffers between humans and animals. Demand for dairy and meat products has led to the expansion of uniform cropland and intensive livestock farming in rural areas and near cities. Livestock often serve as a bridge between wildlife and human infections, meaning pathogens may be passed from wild animals to livestock to humans. Of particular concern are informal markets where wild animals are kept in cages and sold under unsanitary and unhygienic conditions. Viruses and other pathogens quickly spread among animals kept close together, and the humans who handle, transport, sell, purchase, or consume them when sanitary and protective practices are not followed. Climate change is also a driver of zoonosis. Greenhouse gas emissions, primarily the result of burning fossil fuels, cause changes in temperature and humidity, which directly aids the survival of microbes. Changes to habitat due to unusual weather events such as heat, drought, flooding, or wildfires are too rapid to allow ecosystems to balance. Sudden spikes in populations of group species such as mosquitoes, which can be vectors for emerging diseases. Epidemics are very likely to become more frequent as the climate continues to change. Pathogens constantly change to survive in different animals, humans, and environments. With the increase of intensive farming and overuse of antimicrobial drugs in both animals and people, pathogens are becoming more resistant to the very medications that might have been effective in treating zoonotic diseases. COVID 19 is a reminder that human health and environmental health is closely linked. There are about 8 million species of life on the earth, of which animals are just one. This includes an estimated 1.7 million unidentified viruses recognized as the type that may infect people, existing in mammals and water birds. Any one of these could be transferred to humans if we don't take preventive measures now. How can we protect ourselves from zoonotic diseases in the future? The most fundamental way to protect ourselves from genetic diseases is to stop the destruction of nature. Where ecosystems are healthy and biodiverse, they are resilient, adaptable, and help to regulate disorders. Greater biodiversity and ecosystem integrity can help regulate diseases by supporting a diversity of species so that is more difficult for one pathogen to spread rapidly or dominate. With greater diversity, pathogens are more likely to meet effective resilience. Genetic diversity builds disease resistance among animal populations and decreases the chances of outbreaks of high impact animal diseases. Let us now turn to the global and national environmental and ecological crisis. What do we mean by the terms environment and ecology in the context of this book? By environment, we mean the natural world that surrounds us, whereas ecology is the study of the relationship and interactions between organisms and their environment. We will discuss ecology and ecological system in greater detail in the following three chapters. What is happening to the global and national environment? Our environment is not what it was 100 or 200 years ago. We see all around us a rapid degradation of the environment. We also experience an increasing number of unprecedented environmental calamities. The United Nations Environment Programme UNEP publishes a periodical report called the Global Environment Outlook GEO. The latest edition was GEO 6, released in March 2019. Here are the key messages of the report. The overall environmental situation is deteriorating globally and the window for action is closing. Unsustainable production and consumption patterns and trends, as well as inequality, combined with the population driven increase in resource use, put at risk a healthy planet needed to attain sustainable development. Past and present greenhouse gas emissions have already committed the world to an extended period of climate change with multiple and increasing environmental and society wide risks. Air pollution, currently the cause of 6 to 7 million premature deaths per year, is projected to continue to have significant adverse effect on health and cause between 4.5 million and 7 million premature deaths annually by mid-century. Biodiversity loss from an biodiversity loss from land use change and habitat fragmentation, over re exploitation and illegal wildlife trade, invasive species pollution, and climate changes driving a mass extinction of species, including critical ecosystem service providers such as pollinators. This mass extinction compromises its ecological integrity and capacity to meet human needs. Marine plastic litter, including microplastics, occurs in all levels of the marine ecosystem and also shows up in fisheries and shellfish at alarming levels and frequency. Land degradation is an increasing threat to human well-being and ecosystems. Land degradation hotspots cover approximately 29% of global land, where 3.2 billion people reside. Natural resources, including fresh water and oceans, are too often overexploited, poorly managed, and polluted. Approximately 1.4 million people die annually from preventable diseases such as diarrhea and intensive parasites that are associated with the pathogen polluted drinking water and inadequate sanitation. Antibiotic minus resistance infections are expected to become a primary cause of death worldwide by 2050. The harmful impacts of inappropriate pesticides, heavy metals, plastics, and other substances are of significant concern given their high levels in our food supply. On December 2, 2020, Antonio Guterres, the UN Secretary General, gave an address at Columbia University, US, on the state of the planet. The key points in his speech were: humanity is waging war on nature. This is suicidal. Nature always strikes back, and it is already doing so with growing force and fury. Biodiversity is collapsing. 1 million species are at a risk of extinction. Ecosystems are disappearing before our eyes. Deserts are spreading. Wetlands are being lost. Every year, we lose 10 million hectares of forest. Oceans are overfished and choking with plastic waste. The carbon dioxide they absorb is acidifying the seas. Coral reefs are bleached and dying. Air and water pollution are killing 9 million people annually, more than 6 times the current toll of the pandemic. And with people and livestock encroaching further into animal habitats and disrupting wild spaces, we could see more viruses and other disease causing agents jump from animals to humans. Is there a national and a global environmental crisis? Many indicators show a sharp degradation of the environment in recent decades. Here are the significant examples: global warming and climate change. In August 2021, the UN Intergovernmental Panel on Climate Change IPCC released the Working Group 1 report, Climate Change 2021. The physical science basis. Here are the key messages of the report. Human activities affect all major climate system components, with some responding over decades and others over centuries. The evidence is clear that carbon dioxide CO2 is the primary driver of climate change, even as other greenhouse gases and air pollutants also affect the climate. Emissions of greenhouse gases from human activities have been responsible for approximately 1.1 degrees Celsius of warming since 1850 to 1900. Averaged over the next 20 years, global temperature is expected to reach or exceed 1.5 degrees Celsius of warming. In the coming decades, climate changes will increase in all regions. For 1.5 degrees Celsius of global warming, there will be more heat waves, longer warm seasons, and shorter cold seasons. At 2 degrees Celsius of global warming, heat extremes would more often reach critical tolerance thresholds for agriculture and health. Climate change intensifies the water cycle, bringing more intense rainfall and associated flooding and more intense drought in many regions. Climate change affects rainfall patterns. Precipitation is likely to increase in high latitudes while it is projected to decrease over large parts of the subtropics. Changes to monsoon precipitation are expected, which will vary by region. Coastal areas will see continued sea level rise throughout the 21st century, contributing to more frequent and several coastal flooding in low-lying areas and coastal erosion. Extreme sea level events that previously occurred once in 100 years could happen every year by the end of this century. Many of the changes observed in the climate are unprecedented in thousands, if not hundreds of thousands of years. Some of the changes already set in motion, such as continued sea level rise, are irreversible over hundreds to thousands of years. Unless there are immediate, rapid, and large scale reductions in greenhouse gas emissions, limiting warming to close to 1.5 degrees Celsius or even 2 degrees Celsius will be beyond reach. However, sustainable and sustained reductions in carbon dioxide emissions, CO2, and other greenhouse gases would limit climate change. While benefits for air quality would come quickly, it could take 20 to 30 years to see global temperatures stabilize. Climate change in India. In June 2020, the Union Ministry of Earth Sciences released an assessment of climate change over the Indian region. The key message of this assessment were: by 2100, the average temperature over India is projected to rise by approximately 4.4 degrees Celsius compared to the 1976 to 2005 average with disastrous consequences. The frequency of summer April to June heat waves over India is projected to be 3 to 4 times higher by 2100. Over India, summer monsoon precipitation June September has declined by around 6% from 1951 to 2015. In a recent period, there has been a shift toward more frequent dry spells and more intense wet spells during the summer monsoon season. The frequency and spatial extent of droughts have increased significantly during 1951 to 2016. Climate models project a rise in the intensity of tropical cyclones in the northern India Ocean basin during this century. Since the mid 20th century, India has witnessed a rise in average temperature, a decrease in monsoon precipitation, a surge in extreme temperature and rainfall events, droughts and sea levels, and an increase in the intensity of several cyclones alongside other changes in the monsoon system. Water scarcity. Here are some current facts about water scarcity drawn from the website of UN Water. Over 2 billion people live in countries experiencing high water stress. About 4 billion people, nearly two thirds of the global population, experience severe water scarcity during at least 1 month of the year. Today, 1.42 billion people, including 450 million children, live in areas of high or extremely high water vulnerability. 3.2 billion people live in agricultural areas with high to very severe water shortages or scarcity, of whom 1.2 billion people, roughly one sixth of the world's population, live in severely water constrained agricultural areas. When a territory withdraws 25% or more of its renewable freshwater resources, it is said to be water stressed. 5 out of 11 regions have water stress values about 25%, including 2 regions with high water stress and 1 with extreme water stress. 700 million people worldwide could be displaced by intense water scarcity by 2030. According to a report released by Niti Aayog in June 2018, India is suffering from the worst water crisis in its history, and millions of lives and livelihoods are under threat. India's rank is 120 among 122 countries in the Water Quality Index, as nearly 70% of the water is contaminated. Currently, 600 million Indians face very high levels of water stress, and about 2 lakh people die every year due to inadequate access to safe water. By 2030, the country's water demand is projected to be twice the available supply, implying severe water scarcity for millions of people. Excessive air pollution. The website of the World Health Organization WHO presents the following vital facts on global air pollution. Around 90% of people worldwide breathe polluted air. Around 7 million people die every year from exposure to fine particles in polluted air that penetrate deep into the lungs and cardiovascular system, causing many diseases. Over 3 billion people, most of them women and children, breathe in deadly smoke every day arising from pollution stoves and fuels in their homes. Many of the world's megacities exceed WHO's guidelines levels for air quality by more than 5 times, representing a significant risk to people's health. According to the 2020 World Air Quality Report released by IQ Air, the technology partner of UNEP and UN Habitat, air pollution continues to present one of the world's most significant health hazards to people everywhere, contributing to about 7 million premature deaths annually. 6 lakh of these deaths are of children. Air pollution is estimated to cost the global economy upwards of US 2.29 trillion per year, 3.3% of global GDP, due to fossil fuel emissions alone, while also contributing to a range of severe environmental problems. As before, South and East Asian locations emerge as the most polluted globally. Bangladesh, China, India, and Pakistan share 49 of the 50 most polluted cities worldwide. The COVID 19 pandemic emerged as a significant and exceptional factor influencing air quality during 2020. The temporary reduction in fossil fuel consumption caused by lockdowns worldwide correlated with significant decreases in air pollution compared to previous years. Due to the circumstances of these improvements, however, pollutant concentrations are likely to rebound. 2020 also witnessed several extreme air pollution events in the form of wildfires and dust storms linked to increasing global temperatures. Record breaking wildfires ravaged the US, Australia, Siberia, and South America, while, in, while Indonesia and parts of Africa also experienced devastating agricultural fires. These events resulted in significant air pollution spikes in these areas while also emitting copious greenhouse gases. Air pollution in India. There is widespread air pollution in urban India, and the air quality monitoring is also deficient. India is the third most polluted country after Bangladesh and Pakistan. Out of the 20 most polluted cities globally, 15 are in India, including Delhi, Lucknow, and Kanpur. During 2020, there was a record number of stubble burning incidents in Punjab, 46.5% over 2019. Dying ocean. The following ocean facts were presented by the UN in advance of the second UN Ocean Conference to be held in Lisbon, Portugal in 2022. Carbon emissions from human activities are causing ocean warming, acidification, and oxygen loss. Ocean heat is at record levels, causing widespread marine heat waves. Over the past 30 years, there has been an average increase of ocean acidity of 26% since pre industrial times. At this rate, an increase of 100 to 150% is predicted by the end of the century, with severe consequences for marine life. Every year, an estimated 5 to 12 million tons of plastic enter the ocean, costing roughly US dollars 13 billion per year, including cleanup costs and financial losses in fisheries and other industries. More than 800 marine and coastal species are affected by marine plastics through ingestion, entanglement, and habitat change. More than a million seabirds and 1 lakh mammals are killed by plastic debris every year. 60% of the world's foremost marine ecosystems that underpin livelihoods have been degraded or are being used unsustainably. 30 to 35% of the global extent of critical marine habitats such as seagrass, mangroves, and coral reefs have been destroyed. There are now close to 500 dead zones covering more than 2,45,000 square kilometers globally, equivalent to the surface of the UK. The damage was primarily caused by fertilizers entering coastal ecosystems. The fraction of world fish stocks within biologically sustainable levels declined from 90% in 1974 to 66.9% in 2015, degrading land and soil. The Secretariat of the UN Convention to Combat Desertification, UNCCD, released the report Land in Numbers in 2019. Some of the key messages of the report were global estimates of the total degraded area vary from less than 1 billion had had to over 6 billion ha. Increasing misuse of resources and growing demand for goods and services intensify desertification and land degradation globally. The degradation of land and other natural resources is not only an ecological liability but a social and economic threat for many countries. The annual global cost of land degradation due to land use change and reduced cropland and rangeland productivity has been estimated at roughly US 300 billion. Land degradation has already had a pronounced impact on ecosystem functions worldwide, amounting to a 5% reduction in total global net primary productivity. The degradation of the Earth's land surface through human activities is negatively impacting the well being of at least 3.2 billion people. Between 2000 and 2009, land degradation was responsible for annual global emissions of 3.6 to 4.4 billion tons of CO2. Urbanization is projected to cause the loss of between 1.6 and 3.3 million ha of prime agricultural land per year between 2000 and 2030. Land degradation in tandem with the climate change may force 50 to 700 million people to migrate by 2050. Loss of biological diversity. WWF, the Global Environmental NGO, publishes a Living Planet report every 2 years. The key messages of the 2020 report were: in the last 50 years, our world has been transformed by an explosion in global trade, consumption, and human population growth, as well as an enormous move towards urbanization. These underlying trends drive the destruction and degradation of nature, with the world now overusing natural resources at an unprecedented rate. Only a handful of countries retain most of the large remaining wilderness areas. As a result, our natural world is transforming more rapidly than ever before. There was an average 68% fall in monitored populations of mammals, birds, amphibians, reptiles, and fish between 1970 and 2016. Recently, a series of catastrophic events, wildfires, locusts, plagues, and the COVID 19 pandemic have shaken the world's environmental conscience, showing the biodiversity conservation should be a non negotiable and strategic investment to preserve our health, wealth, and security. Deforestation. The UN Food and Agriculture Organization FAO produces a State of the World's Forests Report SOFO every 2 years and a Global Forest Resources Assessment FRA every 5 years. Here are some key messages from the 2020 SOFO. Deforestation and forest degradation continue to occur at alarming rates, contributing significantly to biodiversity's ongoing loss. Since 1990, 420 million ha of forests have been lost through conversion to other land uses, although the rate of deforestation has decreased over the past 3 decades. The area of primary forest worldwide has decreased by over 80 million ha since 1990. More than 100 million ha of forests are adversely affected by forest fires, pests, diseases, invasive species, drought, and adverse weather events. Agriculture expansion is the primary driver of deforestation, forest fragmentation, and the associated loss of forest biodiversity. The net loss of forest area has decreased substantially since 1990, but the world is not on track to meet the target of the UN Strategic Plan for Forests to increase the forest area by 3% by 2030. Progress on preventing the extinction of known threatened species and improving their conservation status has been slow. Current negative trends in biodiversity and ecosystems will undermine progress towards the UN Sustainable Development Goals, Chapter 17. As we shall see in the later chapters, other aspects of the environment, such as waste generation and pollution of natural resources, also point to severe degradation. Further, many of the phenomena are interconnected and often reinforce one another. What is the Environmental Performance Index and what is India's standing? The Environmental Performance Index EPI is produced jointly by Yale University and Columbia University in collaboration with the World Economic Forum. API is a composite index based on performance in 10 areas: air quality, water and sanitation, heavy metals, biodiversity and habitat, forests, fisheries, climate and energy, air pollution, water resources, and agriculture. In general, high API scores exhibit long standing commitments to protecting public health, preserving natural resources, and decoupling greenhouse gas GHG emissions from economic activity. Low scores on the EPI indicate the need for national sustainability efforts on several fronts, especially cleaning up air quality, protecting biodiversity, and reducing GHG emissions. Of the 180 countries ranked in the 2020 EPI, the top 5 were Denmark, Luxembourg, Switzerland, United Kingdom, and France. In that order, the bottom 5 countries were Ivory Coast, Sierra Leone, Afghanistan, Myanmar, and Liberia. India was ranked 168, while Bangladesh 162, Nepal 145, Pakistan 142, China 120, Sri Lanka 109, and Bhutan 107 had better rankings. The rest of the book will discuss the human exploitation of natural resources and its consequences, we being by clarifying the difference between renewable and non-renewable natural resources. What is the difference between renewable and non-renewable natural resources? Since the advent of the scientific and industrial revolution, or perhaps since the inception of agriculture itself, man has been viewing all of nature, water, air, soil, oil, minerals, plants, animals, and even the wind and the sun as resources to be exploited. Therein lies the reason for man's extraordinary achievements. It might also be the cause of man's and ultimate downfall. Our end might come because we do not differentiate between renewable and non renewable natural resources. A renewable resource is one that naturally replenishes again and again over time through its processes. An example is fresh water, which we get as precipitation every year, thanks to the global water cycle. Trees that gives us wood and fruits, plants that yield vegetables, and the ocean that provides fish and other examples of renewable resources. Over time, even polluted air is turned into clean air by nature. There is, however, a condition: we must give nature enough time to renew a resource. If we cut down a tree or even a forest, it will grow back in time if we leave the place undistributed. If, however, we cut or graze away every fresh shoot that comes up, the forest cannot grow again. If we carefully use the water in a well, it will replenish itself every year. If, however, we draw water faster than the rate of replenishment, the well will go dry. The sun and the wind belong to a particular case of renewable source. They are inexhaustible natural resources. They do not need replenishment. A non renewable natural resource, on the other hand, is available only as a finite amount on earth. It cannot replenish itself over human timescale. Petroleum, coal, and minerals are examples. They were formed over millions or billions of years, but we have been depleting them rapidly over the last 2 centuries or so. As a result, we will exhaust such resources at some time or other. However, if we use them carefully, they will be available to us for a long time to come. What are the leading causes of the environmental crisis? We are exploiting our natural resources at an ever increasing rate. In the process of using up the resources, we are also rapidly and heavily polluting the planet. We can say that humanity's ecological footprint is getting larger and larger. What is ecological footprint? Ecological footprint is the area required to indefinite sustain a person, a city, a country, etc. It accounts for the consumption of energy, food, water, materials, etc., and the creation of waste. It is measured in global hectares GHA per person. We can compare humanity's ecological footprint with its biocapacity, biological capacity, Biocapacity is the Earth's capacity to regenerate the biological resources that human beings consume and to absorb the generated waste. To an extent, natural regenerates the natural resources that we use. For example, the annual monsoon replenishes water sources. Similarly, the soil allows us to grow crops every season. Our ecological footprint and the Earth's biocapacity are in balance. Humanity can live and survive almost ide- indefinitely, but that is not the case. What is humanity's ecological footprint? According to current data, our global ecological footprint is 2.77 GHA per person, whereas the global biocapacity is only 1.6 GHA per person. In other words, our footprint is already 70% larger than the area of the Earth. Thus, it takes more than 1 year and 7 months now for the Earth to regenerate the natural resources we use in 1 year. If we persist with our current rate of consumption and waste creation, we will need more than two planets by the 2030s. If our footprint is already larger than the area of the Earth, how do we survive at all? We survive because of two reasons. Millions of people do not even have their basic needs met and they use very little of the resources. The rest of us consume their share too. We also consume resources that rightfully belong to our children and the succeeding generations. When we extract more and more oil from the earth or exhaust the water stored in deep aquifers, we deprive future generations of their share of the resources. What is India's ecological footprint? India's ecological footprint is 1.19 GHA per person, whereas the country's biocapacity is only 0.43 GHA per person. That is, we need a biological capacity of 3 Indias to sustain our consumption and absorb the waste. We have the third largest total footprint after China and the US. What is the implication of humanity's large ecological footprint? Our annual consumption of the goods and services provided by the earth exceeds what it can renew in a year. In 8 months or less, our consumption exhausts the earth's budget for the year. At that point, the earth overshoot occurs. Overshoot means we are drawing from the earth's principal rather than living off its annual interest. This overshoot depletes Earth's life supporting natural capital. What is Earth Overshoot Day? Every year, the Global Footprint Network determines the Earth Overshoot Day, which marks the date when humanity's demand for ecological resources and services in a given year exceeds what the Earth can regenerate in the year. Earth Overshoot Day moved from October in 2000 to July 29 in 2001. How did humanity's ecological footprint become so large? For a long time since man appeared on Earth, his ecological footprint was small and there was no overshoot. Beginning with the Industrial Revolution, however, man has been using natural resources at an even increasing rate. The graph of time versus consumption of goods and services shows exponential growth. We can see that an exponential curve is nearly flat for a long time until it begins to spike. Then the curve moves almost vertical. Many phenomena show exponential growth, and here are the four significant examples. For a thousand centuries since the human species emerged, the world's population increased very slowly. From 1650 or so, however, it started spiking and now the population doubles every 12 years. Global consumption of goods and services began spiking around 1820 and Now it is almost a vertical line. The number of species going extinct every year has also been growing exponentially. The curve was flat for millions of years but started spiking around 1500. The concentration of carbon dioxide in the atmosphere began spiking around 1800 and has been steadily going up ever since. Such exponential growth is unsustainable in a world with finite resources. What is carrying capacity and how does it relate to ecological footprint? The carrying capacity of a given area is the maximum population of a specific species that it can support. We can calculate the carrying capacity of those non-human species with consistent consumption needs. But it is difficult to estimate the Earth's carrying capacity concerning the human population. Human wants as distinct from needs and resource consumption change over time and space. As a person becomes more prosperous, for example, he begins consuming more. Ecological footprint, on the other hand, measures what has already happened. The footprint answers the question how much land was necessary to support the global population in a given year. Under that year standard of living, biological production and technology. Such a measurement takes into account the changing consumption patterns of people. What are planetary boundaries? The concept of planetary boundaries is another way of expressing the human impact on Earth. It refers to the boundaries for specific processes that regulate the stability and resilience of the Earth system. Such processes are the interactions of land, ocean, atmosphere, and life that together provide conditions upon which our societies depend. If we respect these boundaries and live within the limits set by them, we can continue to exist on this planet, even indefinitely. When we cross these boundaries, however, we could generate abrupt or irreversible environmental changes. Further, once a boundary is crossed, even positive actions may not resolve or even slow down the degradation, and we may not be able to prevent catastrophic consequences. What are such planetary boundaries? Scientists at the Stockholm Resilience Center have identified nine key Earth system processes and quantified the first set of planetary boundaries within which humanity can continue to develop and thrive for generations to come. The planetary boundaries are climate change. We can discuss it in chapter 15. Change in biosphere integrity, biodiversity laws and species extinction, chapters 3 and 4. Land system change, for example, deforestation and desertification, chapter 5 and 8. Biogeochemical flows, phosphorus and nitrogen cycle, chapter 2. Stratospheric ozone depletion, chapter 15. Ocean acidification, chapter 6. Freshwater use, chapter 7. Atmospheric aerosol loading, microscopic particulars in the atmosphere that affect climate and living organisms, chapter 11. Introduction of novel entities, example organic pollutants, radioactive materials, nanomaterials, and microplastics, chapter 12. We have now crossed the first four boundaries climate change, biosphere integrity, land system change, and biogeochemical cycles. This crossing is already causing a fundamental shift in the functions of nature. What is Anthropocene? During the past 10,000 years or so, human civilization has flourished on Earth by exploiting the bounties of nature. This period is part of the geological epoch is called Holocene since the Industrial Revolution. However, human activities have increased exponentially and generates a global geophysical pressures equivalent to some of the great force of nature. Such forces inevitably leads to crossing planetary boundaries, placing our future at risk. Many scientists, led by the late Nobel laureate Paul Crutzen, have asserted that we have overwhelmed the forces of nature and entered a new geological epoch called the Anthropocene. How did exponential growth become our mantra? The coming of the Industrial Revolution changed our relationship with and our beliefs about nature. We can believe the following: we are not a part of nature. We are the most important species on earth. We are meant to exploit nature endlessly to satisfy our needs and greed. These beliefs led to others ideas such as progress should be measured only by economic growth GDP. Economic development is the sole key to eradicate poverty and achieve prosperity for all. We need not take into account the nature capital that we use up. The more we consume, the happier we will be. Though it originated in the West, the idea of unceasing economic growth and development has been accepted by most countries as the only way to go. What has the world done about the environmental crisis? Many UN international conferences such as the 8th Summit, Rio Plus 10 and Rio Plus 20 have been held since 1972. International agreements such as Agenda 21, Kyoto Protocol, Law of the Sea, and the 2015 Paris Agreement on Climate Change have come into force. UN agencies, NGOs, and governments have released a series of reports on the state of the environment proposing possible solutions. In 2015, the UN General Assembly adopted the 2030 Agenda for Sustainable Development, which provides a shared blueprint for peace and prosperity for people and the planet now and into the future. At its heart are the 17 Sustainable Development Goals (SDGs), which are an urgent call for action by all countries developed and developing in a global partnership. They recognize that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality, and spur economic growth, all while tackling climate change and working to preserve our oceans and forests. Most countries have enacted national environmental laws, and many countries have made commitments to combat climate change. UN 2030 Agenda for Sustainable Development, 17 Sustainable Development Goals to transform our world. These Sustainable Development Goals (SDGs) are 1. End poverty in all its forms everywhere. 2. End hunger, achieve food security and improve nutrition and promote sustainable agriculture. 3. Ensure healthy lives and promote well being for all at all ages. 4. Ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. 5. Achieve gender equality and empower all women and girls. 6. Ensure availability and sustainable management of water and sanitation for all. 7. Ensure access to affordable, reliable, sustainable, and modern energy for all. 8. Promote sustained, inclusive, and sustainable economic growth, full and productive employment, and decent work for all. Build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Reduce inequality within and among countries. Make cities and human settlements inclusive, safe, resilient, and sustainable. Ensure sustainable consumption and production patterns. Take urgent actions to combat climate change and its impacts. Conserve and sustainable use the oceans, seas, and marine resources for sustainable development. Protect, restore, and promote sustainable use of terrestrial ecosystems, sustainable manage forests, combat desertification, halt and reverse land degradation, and halt biodiversity loss. Promote peaceful and inclusive societies for sustainable development, provide access to justice for all, and build effective, accountable, and inclusive institutions at all levels. Strengthen the means of implementation and revitalize the global partnership for sustainable development. 2020 was billed as the super year in which the international community through a historic series of climate, biodiversity, and sustainable development meetings had grand plans to take the reins of the Anthropocene due to COVID-19 pandemic. However, most of these conferences were postponed to 2021 and beyond. The UN Climate Change Summit called C0P26 COP26, which was to be held in Glasgow in November 2020, took place in November 2021. Sustainable development is the main topic of chapter 17. Why are things so bad and getting worse despite international confidence and agreements? Many international agreements have been implemented poorly or not at all. The same is true of national environmental laws. The question of environment versus development has never been resolved, and there are several differences between the developed and developed countries over environmental conservation. There is a lack of real awareness and information dissemination among the population. There is also misinformation by vested interests, corporations, lobby groups, etc. The rich will not give up their comforts. Politicians only live from election to election, have a short term view, and are unwilling to take unpopular measures for the planet's long term health. What can and should be done now? We should be following ecological principles such as polluter pays principle. A polluting industry, for example, must be made to pay for or repair the damage caused to the environment. Precautionary principle: when a proposed action has the potential to harm the environment, it is preferable to avoid it. Even if there is yet no conclusive proof of harm occurring, this is a strategy to cope with the scientific uncertainties in assessing and managing risks. Full cost pricing: the price of a product or service should include the potential cost to the environment or the cost of natural capital that will be used up. Intergenerational equity: our action should ensure that we do not use natural resources that rightfully belong to the future generations. For example, what will our successors do if we extract all the oil in one generation? We should implement such principles in practice too. For example, shift to sustainable forms of economy, chapter 17. Find ways of using less energy, keep the oil in the ground, and promote renewable, chapters 9 and 10. Adopt organic farming, chapter 8. Consume less and follow a simpler lifestyle that will put less stress on the environment. How should you, as an individual, respond to the crisis? First, you should accept that we are in the middle of a vast crisis. You are no doubt aware that we are facing some environmental problems, but this book may show you that things are perhaps much worse than what you imagine them to be. Second, you may believe that scientists, technologists, and our leaders will find solutions for all the problems. That may be true, but time is fast running out, and we are already over the tipping point in many aspects. The window of opportunity for us to take action to conserve the environment is shrinking day by day. We must take collective action now. Third, even when you understand the crisis, you may believe that the problems are too big and you cannot make a difference. You are partly right. The issues are enormous. Yet you have an ethical responsibility to take action at your level. What should you remember from this chapter? Write these points down on flashcards for a quick revision later. The COVID 19 pandemic is a zoonotic disease caused by human disgraded for conserving nature, and we can expect more such pandemics. Global and national indicators show a sharp decline in the state of the environment. Extreme natural events are now more frequent and more severe than in the previous decades. When an extreme event occurs, its impact on the environment and human communities is worsened by our past actions and policies. We are causing the environmental crisis by exploiting our finite natural resources at an ever increasing rate. In the process of using other resources, we are also rapidly and heavily polluting the planet. Humanity's ecological footprint is already 70% larger than the area of the Earth. India's ecological footprint is three times the area of the country. Our population and consumption are growing exponentially. Such growth is unsustainable in a world with finite resources. We have already crossed several planetary boundaries. By overwhelming the forces of nature, we have entered a new geological epoch called Anthropocene. We can trace the crisis to our false beliefs about growth, consumption, and happiness. Despite international conferences and agreements, things are getting worse. We are unable to solve the dilemma of environment versus development. We must be done to save the planet and humanity. Build the cost of natural capital into the price of goods and services. Shift to sustainable development in alternative forms of economy that consider the natural capital we are using up. Implement national environmental laws and international environmental agreements. Follow polluter pays principle and precautionary principle. Do not use up natural resources that rightfully belong to the future generations. Thank you.